Today, Dr. Wayne
Recording
Jiang
has started.
will be talking about protocols and SOPs to start off the day. So, Wayne, you have the floor.
Okay, thanks, Michael. Okay, good morning, good afternoon, good evening, depends on where you are. We are here like just 6 o'clock in the morning. It's very dark outside in Michigan. Yeah, and it's quite hot and humid now, but well, it's cooler than in Southeast Asia. Well, today we continue our training, our GOP sessions. Today we're going to talk about the protocols and SOPs. Well, it's this is always the main part we need to talk when we are talking about the GOP. And a lot of times it's just like quite complicated when we keep talking about the same thing again and again, and getting quite boring. But I'm trying to make it a little bit easier for everyone. And let's get started. Let me make sure I'm talking about same thing on my screen. Yes. Okay, we do a little bit review what we did yesterday and the connection to what we're going to talk about today. So yesterday we talked about something. We started some GOP definitions. Okay, please look on the screen. And well, we know that we talked about testing facility, sponsor, study director, quality assurance, then the definition of those dates. Okay, study initiation date, the start date, the termination date, and the study completion date. On the list here, I'm going to test you guys. I'm going to ask you guys some questions. Actually, last time I told you I will. On this list, which one is not specifically in the GOP? Doesn't matter. This is EPA, FDA, or OECD. For example, we know study director for sure. It is on any of those GOPs. That's most important part. And also QA is always there. So let's say we talk about EPA GOP. Do we see the FRD there or LRD there? Probably you don't see exactly the word in there, but you do see the research people, research stuff in the SOP, in the protocols. So you will not see exactly the term FRD, field. This is field, okay? Field research director. So field research director. And LRD stands for laboratory research director. So you don't see exact wording. This is IR4 terminology, but this is clear enough. If we want to use exactly term or similar term in the book, GOP book, we probably can use the term as PI, principal investigators, for these people. But anyways, because we work in the system, we know very well. I'm not going to say too much about that. Another one is we probably don't see exactly the term in the EPA GOP for amendment and deviation. We do see amendment there, but may not see so strictly protocol amendment exactly wording, because we typically use a word called a change. So that's a little bit difference there, but we will go through the protocol today. We will talk about all these things. Okay, let's ask the questions. Remember yesterday I asked the question. So we use IR4 protocol as an example. The question number one is, how many times it mentions the contact study director, talk to the study director, get approval of study director, or a similar phrase like that in IR4 protocol, a typical like a template type. Okay, so we can download a protocol from IR4 website and we can count there. Did anyone do homework on this? You can put in the chat box, and I can see you did the homework or not. Somebody maybe say 5. Somebody maybe say 3. Okay. I'm not too sure you did this or not. Well, I'm not going to give you the answer now, but at the end of the presentation, I'm going to ask the question again and see what you found in IR4 protocol. And another one is how many times in this protocol, okay, using IR4 protocol as an example, it mentions LLMV. And this is equivalent to most places. People call that LOQ, but it's not exactly the same thing, but close enough. LLMV stands for lowest level method validation. Oh, somebody replied there, 15. That's a good number. Okay. It's a little bit different from what I calculated, but yeah, we'll figure that out. I'll tell you the number later. Somebody says 30. No, I'm just talking about the lab portion. Okay, the field portion, the other portion, I'm not going to talk about that because it's getting too complicated. I'm a lab chemist. I do the lab work. Okay. Okay. Well, at the end of the presentation, we'll figure that out. Another question, actually several of them. We talk about the laboratory work. How long you need to keep your samples? For example, the field sample. Okay, you put in the freezer. Okay, so we are talking about a holding time here. How long you hold them. Okay, the residue sample from the field. So how long you need to keep them. After the analysis, how long you need to keep them. And also in the lab, after you do the extraction, we are talking about a sample extracts. How long you need to keep them. Well, we are going back to say this is talking about the protocol. We also need to talk about the GLP requirement, but we are talking about the protocol at this time. Or in OECD, GLP, it's a work plan. Okay, and also we talk about the storage sample. Okay, the fortified storage sample, which most likely we will use the word storage SS, storage stability sample, how long we need to keep them. So we can talk about based on our general practice in your labs, and also talk about the requirement. And this is general requirement, and sometimes EPA inspector comes to the lab, they check those things. Okay, I experienced that. Okay, well, I will ask the question again at the end of the presentation and see what the difference between each labs and between our general practices. Okay, here's another one. The question is, what should be included in the chain of custody form? Is it study director information? Is it QA information? It's receiver information, or it's complete sample information? So if you know this question, you pretty much know how about the sample. I mean the shipping, receiving part. Okay. Okay, we will talk about that, and let's go to protocol. Okay. Well, we know protocol is also called work plan in OECD, GOP. Okay. And there's a special definition there. We just put something easy to read, to memorize. It's a document indicates the objectives and methods and all the conduct of the study. Actually, it's more than that, but this is good enough to give the overall definition of protocol. And you will see underneath here, that's a lot of details about the protocol. And most often is sort of like a necessary part, like a requirement for the format. For example, you need a title here. You need some purposes of the study. Of course, there will be a lot of other things. If it is this pesticides, you need to know a lot of different give the detailed information there. So which pesticides, what's the CAS number, and sometimes what is the EPA registration number, all those things. And also for the sponsors, information and testing facility, you need to put it there. And sometimes, for example, if some protocols, for example, Michael develops a protocol, and we identify certain people to do something. We have not selected a field site yet. That means the testing facility is question mark there, or we did not identify a lab because the lab the country we worked with may not have a necessary equipment for our work. Then we will put it there TBD, to be determined, or will be assigned later. TBD, this is typically we put it there. And that is okay. And that is fine. As long as when the sample is there, we know where to ship them. We put it, the lab information there, the laboratory director and the address of the sample to ship to. So that's fine. And because this is protocol needs to do a good planning, so you will put all the dates there, okay, when it's going to be started, when the sample, I mean, the pesticides will be sprayed in the field, and when the approximate time sample will be shipped to the lab, and also the estimated time when the lab will finish the analysis. So all the details, I'm not going to go through every single one because it's really a lot of details. You will get this PowerPoint slide probably later sometime, but you can read them, or you can simply just pull out the GOP, and the easiest one just to get IR4 protocol. Any protocol, you will find exactly the same information there. Of course, there are a lot of other things like clinical study. What we mentioned yesterday is clinical versus non-clinical. So those are there about different things. Okay. Well, let's continue. There's all kinds of detail there. Plus, finally, when you finish the analysis, it should specify what kind of statistical tools you need to use for the lab results. Okay, so I'm not going to go read every single detail there. You probably can find exactly the same thing, or you find something you really want to see related to your work. Okay, so I'm going to say something else because a lot of labs may have good experience on GOP or ISO. Some other labs may just getting started, maybe getting just started. So I'm going to sometimes go a little bit deeper, sometimes go a little bit simpler. So just be patient and just go through everything. So I'm not going to trying to cover everything, but at least to get you to understand the main ideas of the work. Well, I mentioned a few minutes ago, if there any change to the amendment after study director signs on the protocol, okay, if any change there, and these changes could be amendment or deviation here. Okay, so for any reason, any change, okay, it says there, changes there, and this is the thing, you need to document that and ask the study director to approve. Okay, well, these two terms, some people really do not like the deviation. Based on the wording, that means it did something wrong. Amendment is always like in a better term. So a lot of times people want to argue, but my opinion is you do your work, it doesn't matter. This is deviation or amendment as long as you do it in a correct way. It's fine. Okay. The intention to tell the difference between amendment and the deviation is this intended or is this planned to do the work, to make the change? And from now on, there will be the change there planned. Okay, so if it is intended from now on, this is the change and this will be going, and you plan this way from now on, this is going, and that should be amendment. Okay, for example, we talked about that the lab. Okay, when the project got started, we do not specify a lab there. Then we need to issue an amendment. Then there will be a lab there. Okay. If you did something not exactly the same as a protocol, it's already happened, and that is not intended activity. In this case, it's changed, it's deviating from the main purpose, then it's the deviation. But sometimes it's just like in the middle. It's okay, it's study director's call how you handle that. Okay. Let's take a quick look. This is IR4 protocol, and I did download the protocol last night. We can always use that as an example to see. But what's really needed, for example, the format is very important. So you should have all those necessary information on the protocol. This is the typical IR4 protocol, and we will see you on this protocol here. You see the name. We call it a PR number. Okay, which is this corner here. In this case, it's 10574. And for our work, I'm quite sure you will use a similar format as this. Okay, to this format. Okay, and also put how many page numbers there, here, and what is the objectives here, if something. And who is the study director? The study director. Okay. And propose all those dates there, which is here. Then you have the signatures here and here. Okay. And I'm sure for all IR4 protocols, it should be always mentioning the GOP here. Okay, it could be the EPA GOP, it could be OECD. So we know that, well, in this case, we know this is 40 CFR 160. So it's a 40 CFR 160. That is EPA GOP. Okay. Because our work, sometimes we do the work with Canada, and I'm quite confident we always put the OECD there as well. Yeah, it's here. Yeah, it's always put it there. Just in this case, it's equivalent. We can send our data to Canada, and they can share our data. Okay, so that's overall about the protocol. Well, when we go in the next several pages, we will see the field requirement, the field method, and how you spray, how you select the sites, and how you get the samples, how you ship the samples to the lab. Then followed by the number of trials, then will be the lab session. So we will spend a little bit time later, maybe after a coffee break, we will talk about the lab session. Okay. So that's the protocol thing. That's the overall. And you pretty much will see this kind of format for all the studies you see. I'm sure we train people this way. Then the next we talk about the laboratory, we talk about the SOPs, standard operating procedures. This is overall in your lab. It doesn't matter you do the ISO work or GOP work. Sometimes you don't do any of these work, you still have an SOP there. Okay, so that's how you do your work. That's the documentation. So in a GOP study, the most important thing you're going to have to show is on the screen. You need to get the management approval here on the SOP. So basically, the boss, the sponsor, or lab director needs to approve the SOP. And the SOP need to make sure it's science, valid, good, and the data integrity there, because SOP is connection between the science, between the technology, and the regulatory things. So they mix together to give you the direction, the guidance, how you do that in your lab. There's other thing. For example, a lot of times I do the inspection as well, inspect the laboratories. Most likely we will ask very, very basic question, which is, where is your SOP? And some people say, oh yeah, it's in my lab director's office. So the major question, the very initial question is it immediately available? Okay, if the lab director is sitting just in the lab, it's probably okay. But if he or she is in another building, that's a finding. Because if something happens, there's no way you can get SOP immediately. So that's some kind of thing. When the inspector comes to a lab, it's always ask this question first. So the easiest practice, I do that in my lab, is you print a copy and put this copy in each of the lab. Okay, that makes it a little bit easier, because when people say, do you have it? Yes, it's here. You bring it, immediately you find it. So that's immediately available. Okay, well, of course, then the following question is how you control the SOP. So I'm not going to say you just print any copy, lose copies there, but you need to have another measure to control how many copies there and how you do that. Well, after that, you need to have all the historical copy. So once the new version is there, so you need to just get rid of the older copy from the site. Okay, then there will be the details, how the SOP will be doing. So that's all the details. The SOP established for the test system, the site preparation, and all those detailed information. For example, how you receive a sample, how you assign the lab ID for that sample, what is the storage condition, and how you process that, how you extract that, and how you control the access. So that's the detail. This is the detail. This is extension from protocol. Okay, so in the test system, there will be a lot of things you need to put in the SOP. For example, how you record your observations. Okay, so how you do the tests. Okay, how you handle the system, how you give the name, collect the data, give the name, how you get the sample related information there, how you handle the data. Sometimes you may have different ways to handle, but you need to make it, because it's routine based, you need to give it in the SOP to specify how you do the work. And for instrumentation, for example, your equipment here, how you calibrate your equipment, how you maintain your GC, your HPLC, your LC, MS. And when you are talking about maintenance, and is it the routine? It's non-routine. This is specified in SOP. Because if it's a routine, that means you routinely check the work, that's okay. If it's non-routine, how this will affect your results? You have to put in your SOP to tell the difference. And you have to tell, is this related to your work people can find? Okay. How you transfer all those sample from different places or systems or something. And if you work GLP and the non-GLP in your laboratory, let's say GLP versus non-GLP, okay, so you need to have an SOP to handle that. Okay, GLP. Okay, so that's all in the GLP, in your SOP. So SOP is under the protocol. So if your SOP is too broad, it's too loose, you need to follow whichever is more restrict. If a protocol says more details. For example, in IR4 protocol, the recovery, this is EPA, typically EPA requirement, the recovery is between 70 and 120%. And depends on the work. Some work may have a little bit wider range. So in this case, you need to follow which one is more restrict. Okay, so that's how this is working. Okay. Well, let's look at the quick format, and I just provide a comment here. Okay, this is our SOP. This is an example in my laboratory, and you can see there. There are some good things, some bad things. Okay. First is, okay, let's talk about format. And you will see we have IR4 laboratory on this corner here. That's format. We have a line here, and this is Michigan State University here. So it's in all our SOP, it's in the same format. So no matter how you do the work, you bring this to somewhere, people can see, yes, this is your SOP. And you will see it says standard operating procedures here. And you will see all those versions, who issued that. This is 2019. Our versions, a lot of people use version like sequential numbers 1, 2, 3, 4, 5, 6. That's getting a little bit complicated, because when auditor, inspector asks a question, how do I know this is the most recent one? So after certain discussions with different people, then we decided to use the year as the version. Yeah. So for example, if today is 2020, so we use 2020 for that SOP. So basically, every year we have a new set of SOP. Okay, another question is, okay, from last year to this year, it's easy. It's from 2019 to 2020. That's good. How about I have multiple SOPs in this year? I make some changes now. So then the easiest way, we put a letter after that. We can put an A or B or C or D. Unless it's more than 26, then we're going to go different system. But I don't think we will make so many changes in 1 year. So that should be okay. Okay. Then we can tell for sure it's most recent one. It's at least close enough. So that's a good indication. But you work in your case, you don't have to follow this. It doesn't have to follow that. But this is a good thing for people to find. If you have something 2018 there, and you are still working on it, and you will tell, yes, this is old SOP. How you handle these old SOPs. So you need to just have a system, have a measure to remove the SOP old versions from the site. So you need to specify the people who is going to do this. Okay. Then we will say the effective days and the effective ending date there. So typically that's the effective date is who signs on this here. Okay. So we will have the title here. This is title here, how you do the work. This is the GC 6890. Then you will have the details, how you do the work. It does not have to be only 2 pages here. It does not have to. It could be 20 pages, 15 pages. Typically, we make it less than 10 pages. It's easier to handle. So that's in the footnote there. Then if it is a instrument, who is responsible for that instrument? If it is instrument, what is the maintenance? Is it routine or non-routine? Routine or non-routine? It's difficult to write. Wow. So it's okay. So then someone needs to sign this. Typically, that's the big boss. That's the sponsor or lab director. If it is approved by management, that's fine. That typically is the management, which is the big boss of the facility. Okay, so that's our SOP. That's in our lab. Well, I say some bad thing, which I don't say the bad thing. I don't like that. If you see here, yes, you can do that, no problem. What is this? This is referring those manuals. Okay, if you have a GC, you typically will get a GC manual in older days like that. Okay, but nowadays they don't give you the manual; they give you electronic copy. Then you have to print them, put it there. And sometimes the menu is so big, sometimes it's so big. Then in this case, you have to archive your manual or menus. Then your archives will get too big. So if you do not use all the manual, you probably need simply just get certain pages, copy, and put it here in the details. That's better practice rather than refer to the manuals or to some papers or references. So it's your decision what you need to do. As long as you keep those manuals as attachment with this SOP, you are fine. But well, we wrote this way a long time ago, but from now on, we typically just write the details there, make this SOP like 3 pages, 4 pages, rather than you just archive another book like so thick with your SOP. So that's our practice. Well, the next is study director, and that's the most important person in the study because it's single point of control. And if we read the word single point of control here, this is taken from the OECD GOP. But that means the same thing because in EPA GOP is this person responsible for the conduct for the study. So that's equivalent to the same thing, but the wording, exact wording, is from OECD. Okay. So what does study director do? Of course, study director is everything. He needs to do everything, protocol. You make sure everything is followed. Make sure GOP is good. Make sure the data is good, and make sure everything's validated, everything is accurate, and make sure all those test system is in a good condition, and also sign in the final report, sign a GOP compliance statement. And because of he signs the GOP statement, so he is taking the responsibility on the GOP compliance in this study. So that's the study director. So basically, study director is the key point, is the single point of control of the study. He says yes, can move forward. If he's not okay in the process, and this won't go too far. Okay. Well, then the next important part is the QA. So QA should be entirely separated from the system. So that's the most important part, which is entirely separate from the system. So QA will be doing the checking, inspection, or monitoring the work, but QA should not be any part of the study. So QA can monitor all those things, the facility, equipment, personnel, training, your analytical methods, your practice, your records, and all those related controls. So the only thing what QA needs to do, but not to you, QA is only need to report to the management. So QA does not have to talk to you. Of course, he will, but the most important thing is send the QA report to the management, to the big boss, to the sponsor, to the study directors. Make sure this is in compliance. So that's QA. Okay, here's a question now. True or false? For any GLP study compliance issues, the final decision maker is the quality assurance officer. So it's true or false. Well, we just went through this. We know the study director is the single point of control. So in this case, we know the answer. QA is monitoring the work. So that's something. Okay, we will talk about this. I'll give you the answer later. Okay, I know a lot of people put it there. Maybe should be SD, but okay. Okay, we'll go through this. Okay, in this one, okay, the protocol amendment, protocol deviation, okay, in EPA GOP, we say this is a change. So we just make the difference there. So amendment is before it happens, and the deviation is after this happens. Is it true or false? Or separate them, which one is true, which one is false. Okay. I saw a lot of answers there. True, false, false, true. Okay. I'm not going to say anything at this time. We will have time to talk about this a little bit later because we need to separate these two statements and see what we get. Okay. And look this structure here. Is this correct organizational structure or not? So the big boss is on the top, followed by the study director. Then QA is under study director, and all those people working in the study is reporting to QA. And this is definition, management, study director, QA, and all those field and lab people. So is it this is correct, this side, and all these correct or not? And actually, this is 5 different questions there. Okay. Well, we still have time, so we can go through these questions. That's the major thing we need to know. That's the key part of our GOP and how we do the work. Just do a little bit overview of how we do how IR4 is and what we do. So IR4 is doing mostly, I think at least 70%, maybe 75%. I don't remember exactly. I put 75 at this time. 75% of the time and effort doing the food use, like this residue studies, or those tolerance and MRL work. This part is Dr. Braverman's work. Michael is doing a lot of work on the bio and organic pesticides registrations. So that's including the work we are doing here, mitigation work in Asia. That's part of this. But what I'm talking about IR4 in the US. So this part, I don't know. I don't know how many percent. Michael, is it 10%? I assume it's 10%. I put it there. I don't know. That's the question.
Yeah, about 10%. That's a good estimate.
Yeah. Okay. And the other one is ornamental, or about those horticultures. Okay. I think it's similar, about 10%. So, but I'm just using my my impression, what I had before. I don't know exactly the figure now. So that's the part. There's another part is public health. Probably is getting smaller and smaller. It used to be about 5%-ish. Which, for example, are like mosquitoes. Okay, if U.S. troops go in overseas, they need to control the mosquitoes, the pests. That's kind of a public health, because mosquitoes will spread out the disease. So that's something. So I would say this is the key part, main work, what we do within IR4. Okay, so you pretty much know the IR4, how we do that now. It's just pesticides registration. Do you know where this is? You probably see that some computer desktop background like this. Okay, I don't need to say here. Yeah, if you come across this, you will remember next time. Okay, well, this is a little bit old data, but that tells quite a lot of information here. So what do you get from this picture? What do you get from this picture? You will see. Well, I'm not going to tell every single state what's going on. This is where I am located in Michigan. Great Lakes are here, surrounding Michigan. I'm talking about the whole U.S. You will see the sites are generally on the either side of the continent. Is that right? And it's interesting. It's quite empty here. Not so much IR4 activities. That's interesting. And you will see on the East Coast, there's a lot of them there. On the West Coast, quite a lot of them, especially in California. Is it an interesting observation there? Is that right? Do you know why? Do you know the reason? Okay, maybe you can search, find some references there. But that's interesting. Yeah, we have quite a lot of dots here and there, for example, North Dakota, but it's much smaller scale than California or somewhere East Coast. Okay, you will find that. If you have questions, send me the email. I can reply. I can explain something I think it's correct. Okay. This is the SOP in my lab. So if you are interested in getting a copy of that, I can give you a copy. I mean, that's like a whole book. It's probably, I don't know, 200 pages, 300 pages. But if you print them out, so that's the whole our SOP there. I cannot get the most recent one in one book, but the older copy, like this 2010 version, I'm sure I can get the whole PDF version with or without signature. That's fine. Okay, and you will see. Let's go back a little bit. You will see that's very beginning is SOP on SOP, which is how you handle the SOP, how you write SOP there. So that's very beginning. It's SOP on SOP. Then it's about the personnel here. Then it's about the safety. Then it's about the QA. So we know long time ago, QA, quote unquote, is sort of like a QC type. It's part of the lab until a certain time, QA is totally separated. So IR4 started, I think it's 1992, started the GOP in the system. Then QA is totally separated. So QA needs to control their own SOP. So that's our lab will put it there starting this time. It's totally separated. But still, QA did not do the work, but it's just like there's nothing to do with the lab. So it's totally get out of there. Then it's about QC. This is QC. Then it's about all those general audit. Okay, if EPA comes here, how you handle that. Not everyone just can come to the lab, audit the lab. So that's an SOP, how you handle the external, internal inspections. Then it's all, number 7 is a huge one, which is all talking about the general practice in the lab, which in this portion, this part is most labs is just to have this one. Okay. Then the next one, we have, this is number 7, keep going down to this. This is general practice. For example, how you do calibration, how you handle the samples, how you do the temperature monitoring of your freezers, all those things. And you will see a lot of them retired because we don't use them. For example, all those GCs, we don't, there's a GC there. Yeah, we don't use GCs anymore. Okay, we only use LC-MS, MS in our lab. We do have GCs in the lab, but typically we are just letting them sit in there collecting the dust, not using them in the past. I believe the last one probably around 15 years ago, I believe. Yeah, that's the last time we used the GC. Okay, and number 8 is all about the equipment, instrument. So how you run those instruments. Okay, for example, we can see, okay, this is a thermal LC-MS. And this one is GC-MS. Okay, and you can see there are a lot of old GCs there, which already retired. Well, because SOP is there, but we are not using them anyways. Okay. So that's number 8. So if you keep adding your equipment down here, you just adding them to this list. Okay. So the last one, which is number 9, this is the living document. This is your method. So each one, for example, you do difenconazole on a dragon fruit, then you will have a method here. Okay, then you will have a method here. Then you work on pyriproxyfen on papaya, then you will have another one here. And keep going, keep going, keep going. So, so your working method is the extension, is part of the SOP. So, so that's in our lab. So in your lab, it may be different. You may just put in your method as one thing. Depends on the setting. Depends on if you are following our format. Okay, it's okay. We still have time before we do the coffee break. Okay, let's go back to those questions. I know that. Okay, question 1. Remember we talked about how many times? Some people say it's 15 times. How many times you need to talk to the study director? I mean, not this way. I mean, in the protocol, in the IR4 protocol, how many times were there? Well, you can find an IR4 protocol. I can put it out now, but we will do that later. But I'm not going to put it immediately. So I calculated, I think it's 14, but I would say at the least, this is 12. So in the protocol, it's about the 28, 29 pages. In the lab part, It mentioned at least 12 times, maybe more than that. It depends on the wording, depends on how you think about this. So what does this mean? That means this is really, really, really important. So if it is important, say that 3 times. It's really, really, really important. Very, very, very important. So anything because something happens, study director is the single point of control. Okay, just talk to the study director, email him, okay, pick up the phone, call him, okay, this is very, very important. And how many times, next question, how many times in the protocol analysis talking about you have to do LLMV? And another question is how many LLMVs you have to do? Number of LLMVs. And this is in the EPA requirement. It's not in the GOP, but it's in the protocol and it's EPA requirement. So based on your opinion, so let's say your opinion. So what's the number of this LLMVs should be? Which number should be? How many times? Is it 1, 2, 3, 4, 5, 6, 7, 8, or etc. Keep going. Which number? Yeah, please type in the box. Okay, I saw some questions there. What do you mean routine, non-routine maintenance? Okay. This is about the instrumentation. For example, let's use LC-MS, and we need to have a log to describe, to record all the activities. And sometimes we say, oh, this is maintenance. And our SOP need to tell what type of this maintenance is. Is this like annually? We do that annual maintenance, okay? For example, if you use the LC-MS, you inject it 10,000 times a year. Do you need to change something? Same thing as GC-MS. Do you have to change how often you have to change the septum, change the column, or do the column refresh, make sure the system is clean? So another way is it something happened? You break the machine broke in the middle of the analysis. So if it's routine, you do that every 300 injections. You change the septum, and you do every half a year. You do the whole system flush clean. So that's called a routine. So that means it's preventive. It's just you need to do that in case this happens. There's nothing wrong. Your data is good. The instrument is good. Analysis is good. You're running okay. Everything's good. Okay. And also, most likely for every instrument, they do annual calibration, annual maintenance. That's called the routine because the service engineer will come every year to fix the machine, not necessarily fix, to make sure it's working. It's because the machine is drifting away from the standard point. So that's called the routine. Non-routine is something happens. For example, it's supposed to inject 300 times before you change the septum, but you find a leak somewhere, or it's not going very well. You just change it anyways. So that's something you put it there. Well, if you do this is called a non-routine. Why you do that? There must be a reason. You need to write it there. And if, for example, if there's a leak, HPLC, if you don't tighten the column very well, and for some time, some dirt or something block the column, the retention time start to shift, then you need to change the column, you need to clean up the system. That's non-routine because you are not doing this for every 3 months every half year. That must be a reason, or something machine just breaks. Then you need to write down the reason. Why? Then how about the samples you analyzed just before that? Yesterday, I ran a set of samples, okay? That's 20 samples there. And the samples after that, are you sure the samples are still good? Or something right after you finish the analysis, something happened? So that case, you need to tell people, make sure the set is okay. So that's non-routine. So EPA inspectors is very picky on this thing. I'm not sure about other inspectors, other places. If your lab with SOP, your instrumentation, you don't specify routine, non-routine, they're going to go after you and they're going to keep asking you the same question again and again. How do I know this is wrong, this is good? Okay, so it's better to put it there and you specify anything. So non-routine, as pretty much they're gonna ask you again and again and show me the data before that. So that's the difference. Okay, another question here. Okay, if some lab wants to change the extraction method, okay, what the parameters needed to cover for validation for EPA GLP? This is a big question now. Sure about the global study or this international work or the mitigation work, but if we are talking about the EPA GLP, this part is very restricted. In the IR4 system in the US, this is basically a red sign, a stop sign, stop. You cannot change. So say that short, basically, no, you cannot change the extraction method. Okay, it's not that you want to do another validation. Well, of course, if the method doesn't work, the reference method doesn't work, you can do it, but you need to get several levels approval. Study director need to say yes, and you need to talk to the registrant, the companies need to say okay, and possibly you need to have some communication with EPA, possibly. So the study director is the point to say yes or no. It's possible, yes. I don't recommend you do that. So if your work is submitted to EPA, it's better not to do that. So we will go through this a little bit later when we talk about the extraction. I think it's day 4. Yeah. Okay. Okay. Let's go back to our question here. We got the first question answer here. I think it's 14 or 15, but at least 12. Okay, so in this protocol, in IR4 protocol, so how many LLMV we should do and why? Any answer? Type in the chat box, please. Okay. Okay, I don't see any answer there. Okay. IR4 protocol requires minimum 6. This is IR4 protocol. This is not a GLP requirement. This is a protocol requirement. So you will have to do the method validation. That's already 3. And the other 3, you have to go through your work, your sample analysis before end of the study, before the experiment, termination date. So actually 7 is the point most likely will happen, because that's you do the calculation based on the statistical tools, and the 7 use the calculation there, and that using the student t-test, that number is 3.14. Most people use that. because use that the calculation. But anyway, 6 is the IR4 requirement. Okay, let's go on next one. Next question. Oops, 3 times wrong. Should be 6. Okay, we talk about a holding time. For example, the first one we talk about sample, residue sample from the field. How long you should keep in your freezer? 6 months? 1 year? 2 years? Or 5 years? Well, you can always say depends, is that right? But say general practice, or let's say the common sense. What number you should choose there, or in your lab, what's the number? Please type in the chat box so we can share opinion, share your practice with other labs. So if the chemical is very stable, for example, some kind of salt, if you put in the plastic container for like a paraquat, diquat, this is one special one, paraquat. This is a special one. Okay, 3 to 6 months. Somebody says 6 months. Somebody say that. Okay. Okay, this is no exact the answer, but I will tell you what we do in our practice. Okay, one answer is follow protocol. That's a good question. Good answer. Okay. Okay. If it is paraquat, diquat, a very, very stable chemical, we stored one chemical longer than 5 years, and the residue will not change. So it should say depends. Okay. Most likely in our lab, we analyze our samples around 1 year, finish all the study. So if it is longer than 2 years, most likely will be a question mark there. You make sure your freezer is negative 20 degrees Celsius. And if something going wrong, you need to show your storage data, storage stability data, the recovery. So you need to tell. So this is really depends. Okay, if it is extreme case like this, it's 5 years or longer, no problem, because it's a salt. It dissolves in water. If you use plastic container, put it in the freezer, it will last longer than that. And recovery, I did one study, recovery after 5 years, it's like 95, 98, 99. So good. So no problem. And of course, your storage data is the key. For some of them, one compound biphenazate. Okay, let me just write it down here. Biphenazate. Biphenazate. I believe this is the spell. And this one is 7 days. So it depends on the protocol. You are right. That's the correct answer. It depends on the protocol. But this is extreme case. Okay, because we know this one, a biphenazate will be hydrolyzed within 14 days to half time. So unless you work on this one, it's not that long. Okay, so in our case, in our protocol, IR4 protocol does not specify. So another question, another answer here is 3 months for ISO. Special case 6 months. Well, at least our practice, we don't put it there unless this is a special case like biphenazate or paraquat, diquat. So normally, normal case is about 1 year. That's in IR4 lab, in my lab. Sometimes a little bit longer, but that's fine. So it's like this. Correct answer is depends on the protocol, depends on your SOP. So the practice, my experience is if you keep your freezer negative 20 degrees and your storage stability is above 70%, it's typically 2 years is good. But normally we don't do that longer than 1 year. It should be around the 1 year or 1 year-ish somewhere. So I don't give you a specific answer. I give you my practice. Okay. So it depends on your lab. Okay. So let me just erase something. It's too much there. Okay. Let me just erase that. Okay. 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 The question number 2 on this slide. How long do you need to keep your sample extract in your lab, for example? I'm talking about extract, not standards. Just talk about extract. Okay. It's clean enough. Okay. So the sample, the extract. Again, the standard correct answer is based on your protocol, based on your SOP. But in this case, I talk about IR4 protocol. We can read that, IR4 protocol. So what is that? The holding time in the IR4 protocol? 3 months? No. Your sample extract, I don't think this will last 3 months. IR4 protocol for general guidance is 14 days. For specific case like a bifenazate or other ones, for sure, no longer than 5 days, you have to analyze it. Because it's going to hydrolyze. When it touches water, it's going to hydrolyze. The half-life is, I think, 14 days-ish. So after 14 days, you only have 50% left. So IR4 protocol requires 14 days. So it's a mandatory put it number there. Does not mean this is scientifically you must do that. Yeah, sometimes longer than 14 days, you will get a good recovery. But whichever is more restrict, if you follow IR4 protocol, or most likely in this case you will, because it's the same template, the same format. So you need to use 14 days. For all your extract, you extract your samples. After 14 days, get rid of them. Start a new extraction. Okay. For sometimes, if your instrument is down, the recovery is not good, you keep analyze the same extract, it's not a good idea. Yeah, EPA will not buy it. That means you are trying to make it work, trying to quote unquote intentionally make something to happen. So in this case, in IR4 system, it's 14 days. And the next one is how long the storage sample should be retained. For example, after you finish all the study, everything, how long? Okay, I also put it there. We put 6 months, for example, and 1 year, 2 years, and 5 years. So what do you think? Okay, so this is a finish. This is a storage sample. This is after you finish everything, after the study. One to 5 years. Correct answer. Okay. The answer is between 1 and 5. This is IR4 protocol. Our practice is 5 years. unless you don't have the storage room. So after 1 or 2 years, you need to talk to the study director. You want to get rid of some old samples, old storage samples. Typically, IR4 system, our system, we keep it as long as we can, at least 5 years for the storage samples. Okay, so the correct answer is between 1 and 5. That's in the IR4 protocol. Okay. Okay, well, this is also sometimes we call sample archives or something that's at least 1 year after submission of the final report. Okay, this question. So what should be included in the chain of custody form? Okay, okay, is it the study director, everything, because everything need to get approval? Is it the QA, because QA need to do the the inspection? Or your sample need to be received by the lab? Or it's the complete information? For example, include sample ID, include application-related information, field research director, lab research director, storage condition. I got an answer D. Is D correct or not? Well, you probably received the same samples already in your lab. Let's say this is a non-IR4, non-GLP, your ISO or any lab. You think you will get all the information you need to require in the chain of custody form based on what we say here, the study director, the QA, or the signature, or the sample information. Any other question? Any other answers? Okay, what is chain of custody form? That's the sample moving around. For example, you have a sample from the field sent to the lab. They will create a form that's moving around. This sample is moving from New Jersey, okay, Princeton, New Jersey to East Lansing, Michigan. So that form, it's the record to show this sample is moving from this location to that location by how and when. So that's the chain of custody form. So that's for that purpose. So what do we think? So based on what I just explained, so what's the right answer? Okay, any other answer? That we have only one answer, say D. Okay, let me give you the answer now. D is wrong. Somebody C. I got a 3. Okay, got a 1 or 2 C's and 2 D's. I already answered D is not right. Okay, A is not right either because study director is not a part of this shipping. Yes, you need to tell that it's not on the list. Okay, and you need to tell QA what's going on. Does not mean QA's information must be on there. Okay, and you will see it must have a signature of the receiver and a date, what's really going on. Okay, and you do not have to have any of these information actually on the chain of custody form, any of these. Why? You do not have to have complete sample information. You do not have to have a very specific sample ID. There's no field information necessary to be on there. You do not have to be the FAFRD. You could be anyone to ship the sample. It does not have to be the lab. It does not have to tell, you can specify that. This is most important part because it tells where it goes, who received by when. Yes, you do need something to connect to sample ID. You do need to specify for your purpose to tell the storage condition, but it's not on the chain of custody. So the correct answer is C. So that is the correct answer. Yeah, surprisingly, on the chain of custody, even the sample ID, sample information is not necessary. That's interesting. Well, that is correct. If you do the shipping, you know that. Okay, you only know this shipping, let's say FedEx or UPS, they give you the barcode down. You need to connect your barcode to your sample. Not necessarily it will be on the shipping record. Yes, IR4 always put it there. You need to have these, but not necessarily that's the requirement. Okay, the next one for the GLP study or compliance issues there. So the final decision maker is the QA. Is it true or false? We know that study director is a single point of control. For sure, this is false. Because QA is only monitoring. He is not responsible for any GLP compliance. He can tell the boss, this is not a GLP. He cannot make the decision. There's nothing to do with the QA. QA can only report. He cannot make the decision, yes or not yes. Not good. So the correct answer is false. Okay, let's look this one, true or false. So after this session, you pretty much know what you need to do with the protocol. Okay, so the protocol amendment describes things before it happens. Deviation is, okay, this key word is here is before. And this is after. Deviation is after. True or false? Okay, so what is amendment? Amendment describes the change to the protocol. The definition did not say it must be before or after. It could be after. So this is a wrong statement. If after that, after something happens, study director, oh yeah, we change. From now on, we're going this way. It's wrong. Okay, how about a deviation? So deviation is something already happened, then you file a deviation. This part is correct. So if it did not happen, it's not a deviation. So amendment could be before or after. Okay, next question. Okay, well, we got 5 statements here, actually 5 true or false here. One is on this left-hand side. Is this organizational structure is correct? Then we get all those statements correct or not correct. Let's look at the statements. So who is the management? The management, okay, designs the study director, assures the characterization, assures availability, all those things. So this is correct definition for management. Okay, how about the study director? Study director, single point of control, correct. responsible for GLP, correct. How about next one, QA? QA monitors each study and should be separate from the system and independent. That is also correct statement. And all those personnel or lab and field they are doing the work. That is also correct. Let's read from left-hand side and compare to the right-hand side. It's a true or false? True or false? Okay, the big boss is on the top, no problem. Then the boss can hire or designate a study director. That part is also okay. This is wrong. QA should be totally separate, independent. This part is fine. The personnel is below study director, but it is not below the QA because it's totally separated. So you got two things wrong there. So it's wrong. Okay. The key words here is independent and separate. Okay, let's have a quick coffee break. Then we resume at 7:30, 7:40-ish. Let's say we make it 7:40 Eastern time, New York time. Bangkok time should be 6:40 p.m. Okay. Okay, I will have my coffee ready here. So if I come a little bit earlier, I have some other thing to tell. It's related, but yeah, we can talk about something. Okay, see you in a few minutes.